Okay, good morning to all of you, and kindly let us stand for a word of prayer. Heavenly Father, we come before you this morning asking for the forgiveness of our sins. Lord Jesus, find it in your heart to forgive us. We glorify and worship your name for this day, for the safety that you granted unto us to this place, for this symposium. Again, unto your hands we commit this session, today's activities, that Lord Jesus, you see us through. We commit the leaders of this institution, staff, students, that Lord Jesus, you see us through as we continue carrying the institution to the next level. Lord Jesus, we glorify and worship your name. I kindly ask all of you, we say the Lord's Prayer. Our Father who art in heaven, hallowed be thy name, thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. Lead us not in temptations, but deliver us from the evil. In Jesus' name we pray. Amen.
Thanks, Madam Kasuki. And without wasting time, because we'll be having a crash program, there are some of the activities which ought to have been undertaken yesterday, but we didn't carry out them. We didn't conduct them. So on that note, I would call upon the director, who is the chief host, to give us address before he calls the director who is here with us. Karibu, Professor.
Thank you, Mr. Riaga. I want to say that it's a good morning, and we are participants, but I also want to recognize one of our council members, Engineer Wandai, who is in charge of human resource, and you are human resource to us. This is where you are delivering the ideas, so he's also here to observe the caliber of human resource KV has. Engineer, if you, with your permission, I'll give you 1 or 2 minutes, you greet the team, and I've said something. Yeah, so all participants, let me use this opportunity to behave that I'm doing a recap. Yesterday, we had a very successful day. The symposium was graced by none other than Chief Administrative Secretary, so the ministry was fully represented, and we thank the ministry and the Cabinet Secretary, Madam Cecil Kariuki, for seeing fit that she's represented at that higher level. We also had partners from, let me start with ISRI, East Africa. We had the Regional Center, we had Kenya Space Agency, we had Kenya Water Service Trust Fund, we had partners from European Space Agency, in fact 3 presenters. We also, it was an international conference or symposium in that manner. We also had our partners from South Africa, Water Research Commission, and we believe that the making Cave a Center of Excellence was realized. Then we also had presenters, which are you people who are going to present today mainly, from various institutions. Kenyatta University, we had Professor Nywere, Egerton, Professor Nyando. Yeah, I think, and I was told KU had 17, and they're here, PhD students attending this conference. So you see how high level you are. I know many students, we also want to recognize. We called it a symposium with a particular purpose. Symposium and conference are different. This way you saw State House girls, and I think Upper Hill. Yes, there are 2 secondary schools here. We invited 60 secondary schools within Nairobi to nominate students to participate, because you saw when ISRI was presenting, they were very clear. They were saying that the geoinformation starts from that basic level. You need to model these students, start telling them about geography. And now you realize even if you are an engineer, you must be a geographer. And the engineer is next to me, they will confirm. Location issues and attributes. The location first, then the attributes. X, Y, now you also have the Z coordinates, are very critical. So anything you're going to put in space is geographical. It's just a location attribute, the space attribute. So we also want to start inducting the young ones. And this is what I want to, the team, we were challenged that we should take GIS to schools as one of our outreach program. They start appreciating all these location issues. You are told what has happened in Vihiga, and we appreciate His Excellency Governor Otichilo. How is using the geospatial to solve problems. Suppose everybody in Vihiga, so everybody in Vihiga is a geospatial analyst because they can identify their homes. So suppose we start inculcating that concepts. Even the phone you are using is geospatial because it must locate that person where he is when it transmits. You hear them talking about GPRS. GPRS is a location issue. So what am I saying? That KV is on the right track. If we want to be a center of excellence, then GIS will take us somewhere. It's an innovation on our side. Thank you so much. I was just doing a recap on what happened yesterday, and we hope the same thing will happen today. The plenary chair I'm seeing going away, he has a phone somewhere. So I want to take this opportunity to call engineer to say, Engineer Wandai is a seasoned consulting water engineer for many years, supervising many water projects, and also being a council member, say something on behalf of the council now that he's here today. Yesterday we had the chair, so there's nothing wrong to having another person from the council speaking. Engineer, thank you.
Good morning, Bwana CEO, delegates and participants. On behalf of the chairperson and members of the Governing Council of the Kenya Water Institute, mine is just to welcome you again on this second day of this very important symposium. A lot of information regarding the background, the objectives, the purpose of this symposium were raised yesterday during the opening ceremony. Therefore, I will not repeat that. But for those of you who may be coming today for the first day who were not here yesterday, I would like you to feel free and enjoy yourselves in this symposium. There are some exhibitors, I believe they're still there. Downstairs, you can pass by there and see some of the exhibitions from various stakeholders. But I would like to once again reiterate that this is a very important symposium and to congratulate the organizers, the CEO and his team who have put this symposium together with all the partners who are collaborating in this effort, particularly the presenters, the various presenters who are making presentations on various topics related to GIS and Earth observation. As the CEO said, GIS or geospatial information is the way to go, is really the way of the future in terms of infrastructure development the world over. You can imagine more than 100 years ago when the British were constructing the railway line from Mombasa to Kampala. And they were basically using very physical means of doing the route location, walking it through, as they built the railway line, nearly over 1,000 kilometers. Today, in this age and time with GIS technologies, you can actually do your route location on your computer without setting foot on the ground, and later just confirm that while you're on the ground. I can give you another example, the famous project LAPSET, that is a Lamu Port, South Sudan, Ethiopia Transport Corridor. When the feasibility study was done, that was about 10 years ago, I was actually one of the team members on that. And there was no way we were going to walk the route or drive the route from Lamu Port all the way to Juba in South Sudan and Addis Ababa in Ethiopia. But we were able to use geospatial information to do our route planning and later just confirm that through some aerial surveys. And it is only now that the physical works are being implemented that the detailed surveys are being done, and even that is not being done through the old typical methods of walking the route physically. So geospatial information is very important, especially in the water sector. One of the biggest challenges we have in the water sector is non-revenue water, which in this country is anything between 40 to 60% on average. And some of the reasons why we have this huge unaccounted for water or non-revenue water is because the water utilities many a time do not even know who their consumers are, where there are operational difficulties. But now, through geospatial information, we are able to integrate the whole process of water billing and revenue collection with the GIS, and from the touch of a button in an office, one is able to pick out where the challenges are, where the difficulties are, where the water losses are occurring, and also where revenue is not being collected. There was a very good pilot study which was done at the then Nairobi City Council, now Nairobi County Government, which integrated revenue collection from rates and from water billing with various levels of access, such that from the topmost officers within the county government to the lowest, one was able to tell which properties within the entire city were in arrears or were in the green zone, were compliant with their water charges and also with their rates and payments. And this is all possible because of GIS technologies. So I hope that we will take this symposium very, very seriously and take home the information that will be deliberated upon here and conveyed to us. So please remember that we are not just here for an academic exercise, but this is a very practical matter that is very key in taking this country forward, especially in terms of the Big Four agenda that the government is now propelling. If we were to develop this country, we have to embrace technology, and this is just one of them. So once again, welcome, and have a fruitful day of deliberations. Thank you very much.
Can you make another clap? Yes, we are embracing technology, so KEWI also does not want to remain behind. And this will only be achieved through partnership. I want to take this opportunity to revert back to the MCA for the plenary so that he can go and present us.
Thank you, Prof. and Director Ondai. The presenter, we'll be calling one presenter named Dr. Mark Boyd. Mark Boyd is a senior lecturer at the Institute of Geomatics, GIS Remote Sensing at Dedan Kimathi University. He has a PhD in remote sensing, Master in Science, GIS, and Photogrammetry, and Bachelor of Science in Surveying. He is also a member of the ISK and the EIK. Karibu, Daktari.
Thank you very much. So I request that they project my presentation. Good morning, everyone. So good. I think I have been introduced. I'm waiting for the upload of the presentation. I think yesterday they started by most of the presenters were asking, those of us in the academia, they have students, they have mentors. I also think I have students. Maybe by the show of hands, those whom I have already taught as we are waiting for this presentation. Anybody? Yes, I don't want to let you stand. Those are my students. I will talk about overview of remote sensing or remote sensing sensor systems for water quality assessment. I will not really go deep into the analysis, but just an overview, especially the sensors that we would want to use and utilize. Waiting for the presentation. Otherwise, yeah, I can present from what I have here, but I had copied. Yeah, thank you, thank you. So that is, I'll just discuss a little bit of the overview of remote sensing sensor systems. And then I will not go deep into the analysis of this, but then also talk about some of the advancement in remote sensing and discuss, or maybe somehow talk about the challenges that we have as a developing country and maybe the future directions, what need to be done, what we need to do. Slide number 2. So remote sensing or remote sense data is basically able to reinforce the abilities of water resources for researchers, decision makers, and even to monitor water bodies more effectively. This actually utilizes a qualitative parameters, that is measurement from radiation. Parameters that are, for example, the dissolved organic matter, chlorophyll-a, and other pollutants are very essential that most researchers are actually looking at. Number 3, a large number of different sensors on board satellites are always carried to be able to sense the amount of radiation from different wavelengths. So sometimes we call them channels. And this is what we consider to be the key information that we get from the natural resources, the artificial resources that we are collecting. Spectral, that is the number of bands. Spatial is the accuracy, which we talked here about this yesterday, in terms of the size that we can see. And also the temporal, so the number of times it goes round to collect this information, are very key in mapping of resources. 40% of the world's population live actually around the coastal regions and also on the lake shores. This is a big number. So in these environments, the water bodies themselves are actually among the most sensitive environments that we need to look at. Any changes in those ecosystems can actually impair or endanger the habitats of aquatic organisms that exist there. But then again, also sustainable urban water supplies, they require quality data or quality existing available water resources, even in their watersheds, need to be actually protected and continuously monitored. But then concentration of chemicals, sewage from industrial discharges, they need to be taken under more control. Of course, we need water to take, to drink, as someone yesterday said. But then this is the reason that water quality has to be analyzed. We know about the sensor systems, and I think here, as you can see the diagram there, this is just for effective, efficient data acquisition. So we have the spaceborne systems. These include all the satellites that acquire data, information in space. We also have one, which we call it space shuttle. They rarely use it, but it acquires data for some time, duration of time, but this is where, these are systems where even the human person is actually in there. Like, for example, the SRTM, most of you have been using it. Shuttle Radar Topographic Mission. They used the space shuttle. But this took the fellows 11.5 days to cover the whole globe. That's why we have SRTM data. And they came back. So you can imagine people flying 11.5 days in space and coming back, and they have to be taken back maybe 3-4 days to be able to get back to human, become human and, interact with people. Then we have airborne, which is very common for us, and today I will discuss this. So this is flying with the aircrafts, aerial photography, airborne, even synthetic aperture radars, which we talk about a little bit. Aerial television, very not common, but this is to show a view, like a television movie. And then also now we have the existing UAV, unmanned aerial vehicles. And sometimes now when we have the connection with the systems, then we call them unmanned aerial systems because it's connected. So remotely piloted, flying above, collecting data even in real time. Let's not forget the ground-based. These are the surveying. I am a surveyor, so the technologies that we use, the surveyors also are part of data collection because they get point quality data. So effective and efficient manner of data collection. But then sensors, as I said, they collect amount of radiation. This radiation is very important in terms of reflection. This is what we utilize to now understand the indicators that have been developed by most researchers. This would be the total suspended solids, chlorophyll-a, concentration, turbidity, salinity, and even total phosphorus and others. Next slide, please. So then why remote sensing for water quality assessment? They give a synoptic view so we can visualize, you can see how it covers the area. It also gives a synchronized view in terms of understanding, one information coming from the same area, you synchronize, what about after some duration of time? So it will be very important for monitoring. And also provides now comprehensive historical record of water. So we continue collecting data about this place. So we can go back and say, what about 1980? How was Lake Victoria? How was these lakes that Professor yesterday was talking about? So that information is very important. And then it actually prioritizes the sampling locations and field surveying times. These are what used to be done before remote sensing. Water quality was done by using sampling techniques, so we sample points. But now we can use remote sensing to analyze this. Some of the spaceborne sensors, I will not be able to discuss all of them, but just common ones that have been used. And you can actually look at what I talked about, spectral, spatial, and the revisit time is the temporal. the number of times it goes to cover the area. One is the digital globe, which is WorldView 2. This is with a spatial resolution of 1.85 meters. This is very high to about 0.4, so average of 0.3 meters. So 30 centimeter high resolution. And this revisit time is 1.1, so 1 day. We are able to get that data. And then the spectral number of bands that we have is 8. I can rush to, because of time, spot 5. This is a French one, HRG, so this is another one at 2.5 meters spatial resolution. And this revisit time is 2-3 days. It covers the area. Others would include, okay, this is just an image of those. The next one is the image. Yeah, so it's showing some of these sensor systems, WorldView 1, WorldView 2, and then WorldView 3. Spot is there. And this is even, the image at the site is basically to look at the normalized difference of wetness index from spot image that's captured there. Next slide. So in the mid and global, so the one which we call mid and global, which covers larger areas, but again, very high quality information. Here I have underlined 2 because of time. Hyperion. This one I underlined because it's actually available. It's still a spaceborne. But then the number of spectral bands, the number of spectral, so the number of bands that we can acquire from this is 242 and ranges from 350, which is actually the visible portion, to now even short-wave infrared. This is very long, but you have several bands, so we call it hyperspectral, and they call it Hyperion. And then we have another one called Terra Modis. Why I include this one is also because the acquisition time is very fast, 1 to 2 days. But then again, the number of bands is also high. It has actually 36 channels, which covers even up to the thermal infrared. Very good for analyzing smoke, maybe fire detection, and of course recently the volcano which occurred very near the, Congo, near Rwanda. It actually utilizes this. Now the weakness about the MODIS is the spatial resolution is a bit coarse, 250 meters to 500 meters. So that's actually a limitation. But the spectral and the temporal is a bit high. Others, of course, I have included there. Probably will share this. Now we come to the airborne, which I showed, where we fly with cameras, a camera combination together with using aircrafts. And even now, most recently, the flight of using the UAVs to capture the information is still part of airborne sensors. I put one called AVHRR. Most of you have heard about it. Its spatial resolution is 17 meters, and it has 224. Here we are talking about now spectral, number of bands that we can utilize, spectral channels. IMAP, they call it Prop 1, 3 to 10 in altitude, depending on the altitude, so the height variation. So you can actually get 3 meters accuracy to 10 meter spatial accuracy. And the number of channels there, bands is 128. We have ISA, which personally I've used it, and this one has 1 meter spatial resolution, and the number of bands is 288. So spectral is high. And then the others, probably you can have this later. You can see this is all hypercube. The next slide, hypercube of the hyperspectral data. And this sample of data, probably next slide, so that people can see. It's more pictorial, so maybe they are heavy, so loading it and projecting. So the idea here is that the number of bands are very important in analyzing water quality or water assessment issues related studies. Of course, that is a spectral combination of now lines after putting together, about photogrammetry, where you have flight lines, combine them together, mosaic them. So after you mosaic, then you have that. This area there is now looking at the channels, spectral. As I said, they have so many. So now the curve is even smooth curve, as you can see. And you can see the wavelength. So this is the area of interest. So this is between 400 to 1,000. So this is the visible, which is red, green, blue, and then the near infrared, where even we have vegetation, chlorophyll a little bit higher. So this provides information that we can utilize for water quality assessment. We have another one, next slide, microwave radiometers. These are in the microwave, you know, what we call microwave remote sensing. These sensors actually capture information about now details even in terms of available data information in the, maybe in the water bodies. Of course, we know microwave are systems that actually penetrate even clouds. They even give us information about cloud-covered areas. For example, the coastal region is very good to utilize microwave because that area is always cloudy. So but if you use microwave, you can even acquire mangroves and understand issues, vegetation in the seashores. I will not be able to look at this so much, but the TRMM, we know about tropical rainfall measuring mission. These are not, most people are using this to indicate information about even weather forecasting and data about rainfall. Now, related technologies, next slide. There are so many related technologies now. We talk about LADS. This is laser airborne depth sounder. So this is combination when we are flying with those cameras and those sensor systems, we can utilize also this. This provides information on the depth surface of the shores. It's actually still costly, but then it uses two pulses. One where we have the infrared laser, which does not penetrate the surface of the water. So the top layer is computed. And then we have the green laser, which goes below the seabed, and then again reflected back to be corrected. This only happens in a very short time, duration of time. So you can imagine flying at 300 or 2.4 kilometers above the ocean, but able to capture this in microseconds. The difference now, we can compute the sea surface. So when you are analyzing the water quality, you can also analyze and check whether the sea surface is of good quality or not. Water quality assessment, actually, I think I talked about this, the process of understanding the chemical, physical, biological characteristics of water bodies. So next slide. This is best because of, degradation of the quality of water resources that we may need to look at. And then different water quality standards have been developed. I will skip this, the slide number. I'll skip this one. We can share this later. So I say this already because I don't want to repeat that. But we say that key for researchers have been looking at chlorophyll-a, what is actually on this one. What is actually on the surface, chlorophyll content. I personally did a project when I was doing my PhD in Lake Nakuru, looking at algae content, information about algae concentration in relation to the flamingos in Lake Nakuru. And we are still considering on the surface of water, what is chlorophyll-a information. Sensors measuring water quality. Just to give, next slide, to give a key information on which set sensors that you may want to utilize to understand some of the parameters that have been developed. So next slide. We have the Secchi disk. We have the color dissolved organic matters. We use MODIS, SeaWIFS, and Hyperion, which I have already said. For turbidity and total suspended solids, we can use Landsat 7, we can use SPOT, and also CASI, which is in single bands. With total phosphorus, we can use Landsat, TM, SPOT, and MODIS. We also combine band ratios. So this is indices that we can utilize. Water temperature, so understanding the temperature, we normally use the thermo-infrared band for all this. And this can be acquired, as I said earlier, from MODIS, which is very good for fire information, ASTER data, and NOAA AVHRR. So sea surface salinity and dissolved oxygen I have provided there. These some studies which I was part of them. Next slide. We've done something for fish habitats in Lake Victoria. And this was recent paper or recent study which is still actually in progress of publication. And we have actually analyzed from 2009, 2019, and compare what actually changes in the surface information for fish habitat. So this informs the fish people, these people, fishermen, what to do and where to focus for their fishing. If there's any pollution, why the fish are not staying in one area or the other, give reasons on that. Next slide. There was also a study last year which was published with which we published with one of one of my students, and it was looking at the case study of Thrika rivers in Nairobi, around Ruiru, looking at concentration of lead and zinc elements in the river. And this paper has been published, it's available, so when I share this, it can be utilized because of time. So the idea was modeling the spatial distribution of soil heavy metals using a random forest model. The other, next slide. This one is another paper, impacts of Mau catchment on the Great Rift Valley lakes. I think Professor talked about what is changing, but then we were looking at whether there was any impact from the Mau complex on the Great Rift Valley lakes. Limitations of remote sensing, this in water quality. Basically, developing of the models or these kind of systems that we want to utilize can be very adequate. It requires adequate calibration and validation. So even though we utilize the remote sensing, we still need validation. Of course, any remote sensing data or any remote sensing information cannot be presented without validation. Accuracy is also very important. So for water quality, some people can debate and say it might not be good accurate. The spatial, temporal, and spectral, as I said earlier in my slides, might not give it will not give you the final, you cannot get one image or one satellite image that will solve all this. MODIS can be good in one area, but also you can realize Hyperion is good in another area, and similar like that. Cost of hyperspectral and airborne, so flying, the cost is a bit expensive. And then atmospheric interference, we still have this interference. The weather can change all the time, so that can be a major hindrance. Advancement in Earth observation, so Earth observation generally in all the areas, not only in remote sensing, combines GIS, combines ground surveys, all the advancements are coming up. Real-time signal processing, so there's this signal processing in terms of data capture. Fast data acquisition devices, now we have quick, fast devices in data capture, so large area can be covered in a very short time. And then advancement with the unmanned aerial systems, which I said, these are very good in monitoring changes and modeling and mapping. It really helps in a local scale, localized scale. And then feature extraction, now we can realize that we could extract from now high-resolution satellite images or high-resolution images that we acquire, can do feature extraction. There's another thing called data fusion. As I said, the spatial, spectral, and temporal cannot be, we cannot get from one source. Then combining one which is good in spectral, combining another one which is good in spatial, put together is what we call data fusion. And then finally, multi-level integration, data integration, putting together the GIS, putting together the remote sensing, and then even for web mapping, so that when we say we want to look at Kenya, we have certain resolution for Kenya in a web map. But when you say I want to look at Nyeri, then you reduce the area, you localize the area, but you still have very high accurate information. This has happened with, if you're using Google Earth, they use this multi-levels of different levels of integration of the data for application, and that makes it very important. Challenges in developing countries, this is the challenge that we have, or something which I just pointed out. We still have a challenge with hardware, software, and data processing skills are a bit low. The other way is the data storage. It can be limited, it can be expensive because the data is huge. So storing them even in cloud can be expensive. And then high cost of acquiring the sensors. I said airborne, data mobilization, data and mobilization is still a challenge. Restricted access to sensor platforms. I think now this has been cleared. We had issues in terms of using a UAV, a UAS, because I realize even experts here, researchers could go to another country, not so far, like Tanzania, a student doing a project here, but can collect data in Tanzania, but still get data. But here, it was still a challenge to use UAVs, or the drones. Research and implementation in learning institutions still very low. I actually feel I fall in this, where we do a lot of research, but we don't implement them. So these are kept, we keep them. So we need maybe a jump starting so that whatever is developed can be utilized. Strengths in developing countries, our strengths. Now we have coverage of internet availability so people can do more research. And then capacity building, partnership is still progressing. As you saw yesterday, there's a lot of partnership. I saw EO Africa, there's a lot of partnership even where we are here today and more. Some equipments that are available in Kenya, next slide please. We have from the DRSRS, which we had yesterday, was the first one to establish a GIS department. Currently they have actually the hyperspectral sensor, and this one they call it CASI 1920 micro. So this is with the permission from one of their staff. Showed me that we can tell you about this. They also have the camera called IG High light mapper, back to the slide before, 1560. This one combines now the camera RGB, which is the acquisition in terms of the visible area, and then LiDAR, which I talked about, it can collect points. So combination 2-in-1, LiDAR plus RGB area. Then the last one is, we have some people who have this what they call AST field spectrometer. This is actually a hyperspectral, but field. You go to the field, collect. So if I want to look at some maize samples or quarter southern area, I actually collect this. And I realized there are some people who have this. I was requesting and someone told me, you can call so-and-so, they have it, they bought it for their research. So maybe institutions can acquire this. MODI sensor from Dr. Robinson, who was here yesterday, he told me that they have it there at the regional center. So that sensor, this is an antenna which receives. So that means there's collaboration. Future directions, almost last slide, actually the last slide. We want continuous academic exchange programs to continue. So we actually acquire skills. Personally, I would say I'm one of the happy people because I have acquired some of these things because I had to go through exchange programs, which actually requires a kind of continuity, and we'll support that if need be. Project collaboration, it's good to have international and local researchers collaborating together so that we can move forward, which I think it's going in the right direction. Institutional sensitization on equipment, I still feel we still have lack of information. Maybe their focus priority. KW might need to acquire some of this data, equipment, so that they can equip their labs for processing. And then this increase our analysis and processing skills. Local collaboration within ourselves, we need to have MOUs between maybe universities, industry players. If we have those, then the spatial aspects are actually utilized. Industry support, those in businesses would actually want, it's very important if they can utilize what's been produced by in academia to utilize them in the industry. Maybe there's something which happens or which has been solved, but we still struggle out in the industry. And of course, this calls for what you call national spatial data infrastructure. That thing actually started, but I do not know, I'm not aware of how much it has gone, but it was very important so that we can share information. If I need data for Nakuru County, I don't need to employ an expert to go and collect data, which is available by, say, Calro, or maybe here at Kewi, all water information. If we have the national spatial infrastructure, we can collect the information. Thank you very much.
Thanks, Dr. That was quite elaborate, and we would have wished to hear more and more of that.
Thank you.
Yeah.
So if there's any question, I'm still around, so maybe because of time. Thank you.
Yeah. At this point in time, I wish to remind our presenters that now we'll be taking 15 minutes. And I hope our timekeeper, Bwana Peter, kindly remind us if we take more than what is required. So at this time, I'm going to call one of our major players in the sector, somebody who has been with us all along, and is a major player in the water sector. He is Mr. Anthony Mbugo. Mr. Mbugo is the Chief Executive Officer, WASPA, and he has over 10 years experience in the sector. Before that, he had worked for 6 years as a managing director in 2 water utilities, and currently his area of interest is in the areas of water governance. Bwana Mbugo, karibu.
Thank you very much, Professor Hayombe, who is the director at Kenya Water Institute, Director Engineer Wandai, management and staff of KEWI, all partners who are here representing various institutions from the private sector, international institutions, government agencies, water utilities. Good morning. As I've been introduced, my name is Anthony Ambugo, the Chief Executive Officer of Water Services Providers Association. I've realized that this is a very highly technical session. I was not given the opportunity to prepare a presentation, so I'll just make a few comments. As WASPA, we are delighted to join you today here, and we were unable to join you yesterday because, as you are aware, Director, we are also organizing another conference. It is not of international magnitude, but we can say it has international and regional presence, and that is what has been taking our time. But having said that, we recognize the importance of this symposium, and I think it is timely according to its theme in supporting water service provision and water resource management through utilization of GIS and Earth observation technologies. I think as a sector, we have paid attention to technologies including GIS, and as the speaker who has just left the podium has said, it is important for there to be collaborations and memorandum of understandings. And I think a few years back, we had entered into an MOU with KEWI in terms of supporting GIS for water service provision. And it went to the extent of identifying one of our premier utilities in Kericho, where we set up a GIS center. And I think a lot of work has been done with the support of partners, including SWAP, BFZ from the Federal Republic of Germany, and this led to the development of a curriculum so that during that collaboration, we would have practitioners or people who deal with GIS in water institutions come here to be trained for 2 weeks, the theoretical part, then the other 2 weeks, the practical part in Kericho. I think as we have been doing that, we have realized there have been serious challenges because that was not practically possible. And through continuous consultation, I think we relooked into that curriculum. And so far it has been successful because we realized in water utilities, because it is said if you can't measure, you can't manage. One challenge in the utilities is that you are aware the water sector has had reforms with the Water Act 202. So initially it was being handled by government institutions through the local authorities. It mutated until it came to water companies. So some of our infrastructure, like the pipelines, could not even be located. So you can imagine a situation where in Nairobi, the people who are seated in Nairobi water now, they don't understand where some of their pipes are. Find it is technical because, and this is where we have an animal in water called non-revenue water. It used to be called unaccountable water. Because if you don't know where the pipeline is, even if it is leaking, you can't know if it is your water or not your water. But I'm happy because of these technologies now. I think most of it, as has been alluded to, we have a lot of research going on in the sector, but this is not linked to the industry, because we can see there are a number of solutions, and I think the challenge would be to the researchers, those in academia. We are open, our doors are open so that we can have strong linkages to solve this. So I think when we came back, just to what I've said, is that we realized that we could not trace where this infrastructure were. So we designed courses with KEWI, one, to focus on the expert GIS, experts within the utility. that is a long course, around 5 days, short course. But we realize that they are not the only people who handle GIS in the institution. You need people to collect data, like a meter reader. You want to know where the valves are and among other things. So we realize that we come up with courses that can suit meter readers and those ones that can suit GIS experts. And I want to attest that that has really worked well for us, and it is ongoing. And beyond that, because as you are aware in the GIS technologies that are involved, is that there are various models. So we wanted to come with a model that is speaks to the water sector. So if we are talking about certain classes of pipes in Ololaisa, then you have a code that speaks into Nairobi water so that you are not speaking diverse languages. So I think for us, we have made some progress, but I think still there is much to be done within the water utilities. Now, as the presenter was presenting, because we realized for us to be efficient, we cannot avoid technology. You realize, like, for our water connections are almost in every home that is connected to water. And at times you have very difficult customers who can't allow you to come in and read the meter. So if you are to deploy a drone, so kama umekuwa customer utake kufungua mlango, then I just deploy a drone to read that meter. Isn't that very exciting? So that will increase efficiency. So it means at the end of the month, instead of sending people around who will give you at times inaccurate meter readings, you just deploy that like 5 drones. But technology also has its effects. It means these guys will be not employed. You will be phasing out. But the truth is that technology is very important in supporting water service provision. And we believe that in this generation where we have young people in terms of techpreneurs, we have just been talking of tenderpreneurs, but what we are looking in the sector now is techpreneurs. Is that as you're doing research, we have business problems, and we believe that you are able to give us business solutions. So this is very, very good for us, and we would like to encourage collaborations. We are open. It's unfortunate I'm speaking when we are having our conference next week on youth and women in water sanitation space. But what we are encouraging is that one of the thematic area we are focusing on is big data analytics and information in the water system. Because you realize as a sector we lose almost 43%. Monetarily is around 7.8 billion in terms of water losses. So if solutions are available, then you realize that if we are able to bridge that gap and reduce the losses to acceptable standards of around 20%, we don't need even to construct other water systems that is lost will be available. I've seen techpreneurs trying to deploy satellite systems so that when they're up there, if there's a leakage, then they are able to identify if it is water from a municipal system, because the characteristic of a municipal system, the water is chlorinated. So you are able to know that this water is from a municipal system, it's not from any other system. So I think those are some of the technologies we are welcoming, but we have a lot of challenges. And what we are looking on from the private sector, because the public sector, we don't have those solutions, and that is why we are collaborating with you. So thank you very much.
Thank you. Let's appreciate Mr. Mbodo once more. Yeah, thanks for that. I would wish to request if let's confirm the presence of Dr. Patrick Chage Kariuki, if he's around. You can confirm with Mr. Omiti. Dr. Caroline Kabaria, that one I know is around. Then Professor Njoki Karanja, I know that one is also around. Dr. Betty Alosa Mulianga from Eric Nyandimo, and Dr. Joshua Chebio, which I know has been represented by somebody. But Eric Nyandibo, if you're around, confirm with us. At this point in time, I'm going to call Dr. Caroline Kabaria, who is a research scientist at the African Population and Health Research Center. Caroline is a trained geomatics engineer and holds a PhD in spatial epidemiology with expertise in geoinformatics, remote sensing, spatial modeling. She oversees work at AVHRR, evaluating access to services among the urban poor, including access to health, water, and sanitation. Karibu, Daktari.
Good morning, all. Thank you for the kind invitation and the introduction. So, as you've been told, I'm a research scientist, trained in engineering, but moved more into application. And I'm very glad that CEO WASPA came in between me and Dr. Boitz, because Dr. Boitz was very technical. So I'm very happy, but I'm glad to see colleagues here. I'm glad to see people we've worked with before. I have worked as an adjunct lecturer at GIS department at JQuats. And part of my challenge that when I was teaching students is a lot of students are taught very technically, but sometimes you don't know where to apply. And the GIS world and the Earth observation, which we used to call remote sensing, now we call it Earth observation, has wide application. And so for me, I went into the health sector, looking at how we can solve challenges of facing population and health, and how this can be done through spatial modeling. And so I'm going to give a presentation over the work we do now. I am based at AVHRR, as you've been told, which is a research center here in Nairobi, established about 17 years ago, looking at matters of population and health. And I particularly focus on urban areas and consequently the disadvantaged in urban areas who are the urban poor. So my presentation is titled the Mapping the Urban Sanitation Challenge, but that can be extended to include water and sanitation. So as we know, 90% of the population globally, the increase by 2030 is likely to occur in low middle income countries, and majority of this is going to be people living in what we call deprived areas. So if you're thinking about Nairobi, estimated 60% of the population actually lives in unplanned settlements, which come, of course, with the challenges of access to services ranging from health, water and sanitation being key amongst that. So I just want to give an overview of projects we are doing. So we have a project which we are calling the IDEA Maps, which is basically integrated deprived area mapping systems. And the challenge with this, it tries to look at, so if you go to the next slide, Patrick. So in the next slide, the challenge we have is about integrating how data is collected. So we have a siloed approach of data collection. So if you have to think about the Earth observation and the GIS, it stands distinctly separate from household, for example, or field data collection. And there's still, again, another disjoint if you have to look at sensors and surveys. And then if you have to go further into the spatial modeling or the computer models, there's advantages or disadvantages of using all the methods. So I have highlighted those. So for example, field mapping are most accurate and can be very context relevant. But unfortunately, they can be very expensive, so they cannot be scaled across cities, for example. If you have to think about sensors, they are wide covering, but then most of the time, they do not recognize slum households. So if you have to look at the current sensors, they either classify a household or urban or rural. And of course, in programming, including in health, even in maybe in the water resources, it's always assumed that urban populations are doing better, and so a lot of resources are derived towards rural population. But they are actually, like studies we've done have actually shown that sometimes people living in slums, their health outcomes are even worse than the rural communities. If you have to think about the Earth observation, it can be scaled across cities, but most of the time we'll miss the local context. So if you're looking at, for example, an urban area, you're able to look at the physical morphology, but you cannot tell about the context of the population that lives there. Thinking about modeling, the same thing, you can be able to scale it across cities, but then it is divorced again from the local context. And so the idea maps network is trying to think, how do we bring all this together? How is it you can encompass the Earth observation, GIS remote sensing, and be able to mix it with sensors and surveys, and be able to incorporate the field mapping to be able to have an accurate picture of what is happening on the ground. So the next slide will show just a sample of what you'd think about what is a deprived area. How do you define the boundaries of a deprived area? I'm not going to dwell much on that. So that project is a project that we are coordinating. I am the lead PI, and our partners are in the UK, the University of Warwick. We have partnership from the University of Twente in the Netherlands. We have the University of New York and the University of York in the UK, George Washington University in the US, and the University of Chicago in the US too, University of Southampton in the UK. So this idea has been extended, and the reason I'm speaking about that is because I was told to also think about what are the capacity building capacities, the opportunities that we may have. So like, for example, the ideas map work has been extended into Khartoum. We are working with the city departments of urban planning and the city department of social and labor. And what we are doing is identifying employees of the city departments who are trained in GIS, and they are receiving advanced training through the University of Twente and the Free University of Belgium and AVHRR. So a combined training of applications of the Earth observation, but combining that with the field and the community mapping. So we have a program that is ongoing online. As part of that, they will go to the University of Twente, and eventually they'll end up here in Nairobi, where we'll work with them on the field mapping. So that's the reason I'm bringing that up. So if we go to the next slide, next please. Again. Next. Next and next. Right, so part of the work in thinking about field mapping is the participatory mapping. I don't know if you can go to the previous slide, you have skipped. So part of the work is working on participatory mapping with communities. So printing out large satellite imageries, and as you can see in that picture, we have ladies from the slums sitting to tell us, for example, what are their sanitation challenges, what are their water challenges. And so they are able to identify where are the water points, where are the various points of pollution. And so this is done through a participatory approach where we have working both with geospatially trained staff, but also integrating the communities, and be able to identify areas of concern. And as you will see in the next slide, that's part of the work that we used. And the next slide shows, like, for example, the outcomes of location of water points within Viwandani. So Viwandani is one of the villages in Mukuru slums just across the road. So the final work I will speak about is, again, thinking now specifically to the urban sanitation challenge, thinking about citywide sanitation provision. And this is work that AVHRR led and encompassed both field-based data and qualitative interviews. That would be in the next slide. Right, and so this was done in partnership with Nairobi Water and Sewerage Company and the Water Department of what was then the City County Government Department. Now they are under NMS. And Sanergy, who is a private enterprise based here in Nairobi, providing sanitation solutions to the urban poor. And the outcomes of that, in the next slide, you will see is what we call the Nairobi sheet flow diagram, which tries to trace sanitation provision right from the household to treatment, to be able to identify which areas or where you're having leakages into the environment. And as you can see from that, this was done in 2012. no, not in 2012, in 2018. And as you can see, our evaluation shows that only 34% of waste within Nairobi city, so this is a citywide evaluation, only 34% is safely managed. And that is in line with SDG goal 6.2 about safely managed. And a big chunk of the poorly or unsafely managed waste within the city is coming from people who are not connected to the city, to the sewerage network. So what we call the non-sewered sanitation. About 30% is actually ending up in the environment. And so these are people who own pit latrines or septic tanks who are emptied, but the waste never gets to the treatment plant. And of course, that, like in the city of Kampala, that is a challenge that has been addressed through GIS, where you have the exhauster trucks actually tracked using GPS to see once you empty waste from a septic tank, does it actually make it to the treatment plant? So there is a challenge or an opportunity even for the young people here thinking about innovations of things you could do. There's an opportunity. How can we track waste within the city? How can we track within the city sewer network? About 10% of the waste does not make it to the treatment plant in Rwai. What can we do about that? So I think that brings me to close to the end of my presentation. I'd been told to speak about capacity building opportunities. They are not on the slide, I wrote them later. So within APHRC, we have a research capacity strengthening division. And within that, we are able to raise funds sometimes that are very specific to the sector. So I think in the last 4 years, we've had calls out for fellowships. And this is under a program we call the African Doctoral Research Dissertation Fellowship Program. So recognizing that a lot of people start their master's programs or they start their PhD programs, but they are unable to finish at the point of the project. People lack funding for conducting the research. They lack funding to complete their dissertations. So this was funded by the Gates Foundation, and that was part of the project when we were doing the results adjustment of the Nairobi sheet flow diagram. And under that, we were able to fund 3 PhDs in East Africa, one here in Kenya based at JKUAT, there's one at the Makerere University, and one at Athi University in Tanzania. We were also able to fund 3 masters at that level. So these are PhDs which are almost complete. But we also got some additional funds where we had a call, I think, late last year for master's fellowship. So these are all targeted at people who are enrolled for advanced training, but they do not have the resources to actually complete that. And so that's one way of the model we do, other than just the research that we try to use to ingrain training or capacity building opportunities within the training, within our research departments. So another one is what I've elaborated, for example, in the Khartoum city. So we're able to support ministries and government departments in building capacity. So one example is what I've spoken about we are currently doing in Khartoum. We have, for example, MOUs for research support and fundraising with Nairobi Water. We are also supporting the Ministry of Water and Sanitation and Irrigation, and part of the support we did was running, I think in 2019, the Kenya Sanitation Conference. At the same time, within our projects, we also embed further training. So we are very big on advanced training, masters and PhDs. So we have 2 PhDs going on with the Liverpool School of Tropical Medicine and the University of Warwick. So I would like to conclude by just showing the last slide. I'm glad CEO WASPA is here. I thought it would be a missed opportunity because I am chairing the Scientific and Technical Committee for the WASPA Youth and Women Water and Sanitation Conference that is happening next week in Naivasha from Wednesday. And I would like to extend an invitation for the people attending this symposium to please come and join, particularly the youth and the women. And we actually have a session that is very specific to Earth observation and GIS. So a lot of people frame it as big data and AI, but we are very specific about GIS and Earth observation. So with that, I'd like to thank you for listening. I hope I didn't extend my time. Thank you.
Thanks, Madam, for that service to mankind. Let's appreciate her once more. At this point in time, I'm going to call an online presenter, and that's Professor Faith Karanja. She is an associate professor and the chair, Department of Geospatial and Space Technology, University of Nairobi. Areas of specializations are remote sensing, GIS, research interest in Earth observation, applications, and spatial modeling, gender mainstreaming in STEM, and mentorship. Thanks, Madam. Karibu, Professor.
Thank you, Prof. So I want to start sharing my video. I hope I can be heard. Can somebody kindly confirm they can see my screen?
Yes, we can.
Thank you very much. Yes, and like you have introduced me, I'm Professor Secchi from the University of Nairobi, and currently I'm the chair of the Department of Geospatial and Space Technology. And I'm happy to be part of this symposium just to share a few thoughts on capacity building, basically by Kenyan universities for resource mapping, and of course within the context of GIS and Earth observation. Before I get to in terms of capacity build, contextualize, you know, where we are in terms of globally and even locally. Because when you look at the SDGs, which espouse generally the, you know, the societal issues that need to be addressed by 2030, you find that most of the SDGs basically will require, actually virtually all of them, at different scales. And I'm happy my previous speakers have, you know, are people who have geospatial or geomatic background, and they have tried to elaborate on some of the issues that I would have wished to talk about. But nevertheless, because that's also my background, we just want to emphasize what the universities are doing in order to support some of these initiatives. And so SDG 6 is the one that speaks really to this conference on clean water, the statistics, you know, that that are there in terms of you know, sanitation and of course access to water. You find that we are really, you know, in a dire situation. In a dire situation in the sense that if you look at access to water, particularly in the African context, you find that the situation is really, really bad. And so for strategies and mitigations to be put in place, there need to be, you know, there's need for data and information in order to support various programming and strategies that speak to the various needs. And when you look at the SDG 6 targets and indicators, you find that SDG 6 has actually a total of 8 targets out of the 169 SDG targets in total. It also has 11 indicators that are used to track the achievement of the 8 targets, and this is among the 232 unique indicators. And I try to extract these indicators and targets in order to try and see, you know, where does, or what would be the role of spatial or GIS and Earth observation in trying to contribute to addressing the challenges in as far as access to water and sanitation is concerned, in as far as this SDG 6 is concerned. And when I looked at the indicators, which I'm not going to read out, they're there and they will share also the presentation. You find that for us to be able to track and inform the achievement of, or the miss of the targets, we actually require spatial information. Because when we talk about the proportion of, for instance, of population that is using or that has access to safe drinking water, so the question therefore comes in is, where is this population? And so location therefore again, this is a map that I just got from the internet that looks at the water poverty index, and we look at the African continent rather. Like I indicated, you know, we are actually in the low and very low water poverty index. Again, that tells us that we need to have disaggregated data so that we can be able to address the needs as they are on specific or in specific areas. Again, global water surface, we want to be able to monitor the global water surface in terms of where our total global water is, and for us, again, for us to be able to do that, we need to have sufficient information. We want to monitor our fresh water. We want to be able to monitor our surface water and other fresh water, and you know, the dynamics as it were. So spatial information comes in handy. And so as I mentioned, when we look at therefore the GIS and remote sensing, which is basically the underpinning of this symposium, the role therefore of GIS and remote sensing is to be able to solve location-based problems, and I've just mentioned that. GIS remote sensing, again, we are able to carry out simulation. We want to be able to find out the what-if scenario. It does provide us with that capability, or the tools provided with that capability. We are able to support innovation because we are living in a dynamic world, and a world that is fairly complex in terms of the solutions that are required, and therefore a lot of innovation are needed. We are talking about not only using like the traditional Earth observation systems. We are talking about now involving things like UAVs. I was happy to hear, you know, the people saying that if people don't open gates for the meter readings to be done, then they send the drones there. You know, that is innovation. We want to be able to employ innovation in order to address challenges that we have continuously talked about, and we cannot continue being there forever. Support, research, and training. Again, geospatial technologies provide that platform. Big data analytics. Again, we deal with lots of data, and therefore the platforms we need for us to be able to address this are the big data analytics framework. And last but not least, visualization. At the end of the day, we process this data, regardless of the platform, we need to be able to visualize and communicate this information, package this information for the intended use. So we see that there is an important role the GIS and remote sensing, or GIS and Earth observation plays in helping us, you know, address natural resource challenges among many other applications. So when all is said and done, so what is the core mandate of university? I'm taking a different trajectory from my colleagues who have ably talked about the technical issues, but I mean, in order to build capacity for this kind of field or area of application. So it is teaching and learning, consultancy, research, community service, and now mentorship. So you find that when you look at the core mandate of the university, regardless of which university and maybe the terminology that they use, you find that this is now the model of the universities. They are now realizing that they cannot continue being in the ivory tower. They have to be able to address the challenges that we are experiencing, you know, at the grassroots level. And so when you look at the model of traditional universities, the model was focusing basically on just training and research, you know, regardless of the societal problems that were being experienced. And therefore there has been a paradigm shift. We are talking about 21st century universities model. And at the center of this model are the societal needs. So what are these societal needs? When you look at the societal needs, we are talking about water issues, we are talking about environmental issues, education, you know, our wildlife, we are talking about, you know, dealing with hunger, you know, I'm glad Caroline was just talking about the urban poor. So there are all these societal needs which can only be addressed if we have the information and data that can be able to support the programs and strategies that need to be undertaken. And so you find that the problem-solving approach models, the current models are based on actually doing observations, being able to actually interrogate what is the problem, what is the hypothesis that we need to address, carrying out some experimentation or analysis or simulation in order to come up with a conclusion. As opposed to the traditional model, where basically it was just about memorizing, trying to imagine a problem and trying to recite. That has been overtaken by events now. We are in the 21st century, and so we are looking at 21st century skills, where the 21st century skills revolve around critical thinking skills, fostering collaboration, which has been elaborated on, problem-based learning, and innovation. And so for universities to survive, they have realized that the model has totally to change in order to speak to these needs. They have to be able to come up with programs that develop capacity for the 21st century, that are going to help the graduates who are coming out into the labor market to have the right skills and knowledge in order to fit in the world that we are currently existing in, so to speak. And so just to emphasize on that, so we are saying that the current global market requires graduates who are creative and innovative. And of course, geospatial technologies, where GIS, as observation, falls in among other technologies, provide such a platform. Most of the decision making, like I've just mentioned, is dependent on location information. And therefore, what universities are therefore doing and have recognized, they need to position themselves by having programs that offer cutting-edge technology and problem solution center. And so I decided to do just a quick survey on some of the universities, that offer some aspect of geospatial technology, programs, if you like. And so I decided to just run through this and just have a look at the statistics, and we see where we are. Do the universities recognize the importance of addressing, natural resources? And so when I did that, this is just a slide again, just to emphasize geospatial technologies, which I'm sure by now you're converted after all the lectures that you've had, or the speakers who have spoken. So I looked at the status, first of all, of universities. So how many universities do we have? I looked at both public and private, as well as public constituent colleges. So the statistics are there. But most importantly, I wanted to look at which universities recognize that it is very important for us to have some elements of geospatial technology being taught, or some skills and knowledge being imparted on our graduates. So I looked at engineering, because engineering, within the engineering programs, we have some aspects of geospatial sciences or technology being taught. We have programs that are just fundamental on geoinformatics or geomatic engineering, physical sciences, computer science, natural resource management, as well as wildlife. And the statistics are there. And so what you notice is that we still have very few, institutions that offer geoinformatics or art sciences as standalone programs. But we do have some elements of these geospatial technologies being taught within other existing programs. That tells you that they recognize that this program or these skills are actually important for what to survive there. And the situation and the statistics are also there. Even in the constituent colleges, again, we recognize that they are also being offered to some extent. And so with that, what I basically wanted to emphasize with my talk, and I hope I'm also within my time frame, is that universities now are alive Now there is a delivery effort for the uptake of research in order to, and strategies in order to address the various challenges that we experience as a society, and that includes, management of natural resources, where of course water falls in. Thank you very much for your attention.
Yeah, let's appreciate the professor once more. At this point in time, I want to recognize the presence of one of the Institute's director, Mr. Festus Mwanzi. He has just joined us. I would also wish to recognize the presence of Dr. Onywere, who has also come again. We're going to call our last presenter, and after that, we'll break for tea. We also need to remind ourselves that there's exhibition going on. So let's have a taste of what the exhibitors have for us. I'm going to call Dr. Jane Ndunga, who holds a PhD in Biological Sciences, University of London. He is currently the Deputy Director, Forest Biodiversity and Environment Management at Kenya Forestry Research Institute, that is KEFRI. He has been the Regional Director in KEFRI's eco-regional programs, both the dryland programs and the Lake Victoria Basin. He has been involved Yeah, it is a very long one, but because just as I told you, sir, reading this scholar's resume is just like presenting itself. But we'll invite him now to present.
Good morning, ladies and gentlemen. Thank you very much for that introduction. Basically, I work for KEFRI, and I don't have a formal presentation, so I'll just give an informal presentation. I think we have been talking about water and GIS. I must confess that I'm not a GIS expert myself, but we have been using GIS in our institute. Basically, our mandate of KEFRI is to conduct research in forestry and other island resources. Two is disseminate that research finding to various stakeholders. Three is to build the capacity of various stakeholders to be able to conduct aspect of forestry, and of course establish partnership with other stakeholders who are doing issues to do with forestry. Then how do KEFRI contribute to, how do KEFRI uses the GIS? I think as it relates to water, most of the water comes from our major water towers. You've heard of major water towers like Mau Complex. You've heard about Cherangani, Mount Elgon, Aberdares, Mount Kenya. That's really where our water comes from. So we are really tackling the problem from the source. And of course, we have had a lot of challenges in terms of the degradation of these water towers, which means the recharge of water or the flow of water from these sources is reducing. You've heard about the challenges to do with Mara, the challenges to do with water supply to Nairobi. It's because of the forest degradation in some of these areas. So we have been using GIS to sort of monitor degradation over years and relate that to water supply and water quality. So I think that's one of the major areas that we are trying to use to be able to, in the planning, and be able to advise stakeholders on the restoration technologies that can be used to restore those particular water bodies. So we have been, our mandate is basically to develop those particular technologies to see how can we best restore. So we use GIS to map some of those forests, look at the trends over years, and look at localized areas where we are going to conduct the restoration in terms of bringing back the vegetation into effective use. So we have developed technologies that we are guided by GIS to sort of target those particular technologies. And one of my colleagues today, who is our GIS expert, will be able to present some of the technology on aerial seeding that we have used in Mau complex, and we'll look at what are the successes in terms of the restoration. We have also used GIS in what we call ROM technology. That's restoration opportunities, assessment, and monitoring. And we have done that in a number of projects that we have been conducting both in the dry areas of this country, like Mount Kulal in Marsabit, where water comes from some of the remnants of the forests in that particular area, and they serve the communities in the downstream. So we have been using those particular satellite images, GIS technology, to be able to monitor those particular changes. We have also been looking at various species, and I was happy about my colleague who made his first presentation, trying to see what were the original species that were in those particular landscape, so that as we introduce those technologies back into the landscape, we are doing what we are called species site matching, so that we are not just introducing species which will be able to deplete the water resources. So those are some of the areas that our institute is really working with the various researchers to be able to restore those particular water towers into their original forms. Lastly, we also do capacity building. KEFRI has introduced a graduate forestry school, and we are encouraging a lot of scientists, researchers who are basically doing their research work to be able to come and conduct research in our institute. And you can be attached in any of the section dealing with either forest hydrology, looking at what are the restoration aspect, looking at water use efficiency of some of the species, and also monitoring the water quality along those particular major water towers. So I think I want to go into the details. My colleague will be making a presentation. He's our GIS expert, and he'll be able to give you more detailed presentation. Thank you very much, Chair.
Yeah. Before I take the microphone to Professor, we need to recognize also the presence of Hospital Hill students. They were here yesterday and they have come back today. The State House girls, Pia also, we have recognized your presence. That is very good. We've been told that GIS should start at the very low levels, not even at high school. I would wish to request all those who have presented and the directors of the institute that we have a photo session outside. It is also important to note that we'll be having 3 sessions, and you need to know the chairs so that you know where they will be. At the conference room, our main conference room will be having Mr. Gitonga. Gitonga, stand up so that you can be seen. Then in this particular hall, we'll be having Mr. Omiti. Omiti, maybe you'll make those announcements you want me to make. I'm not getting this. Then on the last one, we'll be having Madame Beatrice. Beatrice, stand up so that you are seen. That will be in another hall down next to the exhibition center. So kindly have a taste of our exhibition once more, what the exhibitors have. And those who also are presenting, for the last time, maybe for purposes of planning, you can see Mr. Omiti. Thanks a lot. But let me now call upon the chief host, if he has a word or to welcome us, if he has something for us.
Thank you so much, the MCA, the Deputy Director of Corporate Affairs, and he's been doing a very good job, because that is Corporate Affairs, trying to interact with partners. So can you thank for the Corporate Affairs Deputy Director? So this is partnership, this is outreach. So I want to thank everybody that came today. We'll meet again in the plenary. But it's not bad to say that the presenters, those who have presented, we wanted you to present to the entire plenary so that we can know how to partner. Madam Kaberia, Doctor, is it Africa? Yes. APHC, that is health research. Thank you so much. Dr. Boyd is reminding me that we were in Moi together. Thank you so much for representing Didan Kimathi. Professor Nyera has also come and he presented yesterday. We are appreciating you because if you want to do research in Kenya or sanitation now, that's the function that's been given officially by Kenya government, has given to Kenya Water Institute. So make sure that you include Kenya Institute as a partner. If you want to do any research, whether it's foreign funding, include Kenya Water Institute. Our Act, the KV Act 2001, and even the one we are writing, the new bill, 2021, has given KV that mandate to train, research, do outreach, and consultancy. So even if you're doing consultancy, make sure that KV is part of you, because we'll be telling the government that this consultant is not correct. That's a mandate that is given to us by an act of parliament. So we are trying to make sure that those mandates, we action them, and one of them is the outreach. This way we outreach everybody in this conference. I'm inviting you for a group photo, because you might be there yesterday, but you are not in front. So all presenters will be in front, and the governing council member. I want to recognize Mr. Festus Mwanzia. Can you wave? He's our treasury representative. So when KU does not have money, he's the one we ask. But he's seeing we are spending the money well. We have outreached many people, including State House girls. We have outreached Upper Hill. And we were supposed to have 60 schools represented. But I think next time we'll have many, so that they start knowing that this geo is what makes you be an architect, an engineer, hydrologist, geologist. They're all geo frameworks of geolocation issues. Even health now, you see health and sanitation is geo. Epidemiology is geo. Yeah, I think that's the announcement, and I think there's some tea. So we also take some tea, and then we break to the respective, which has been mentioned, respective, there'll be 3 conference rooms going on. So the faster you do it 10 minutes. Most things have been said, don't repeat. Say what your project is bringing to the table. Don't go to a lot of theory. And you see, we've been taught all theory since morning. So we now know theory, we know remote sensing, we have taught waterbodies, we have taught IKONOS, we have taught many things since yesterday, from Europe to local. So make sure your presentations are 10 minutes and you go to the project itself. What are you achieving with the GIS? The way the student did very well. When we took the CS round, they were specific on what their projects was up. I was given only 2 minutes. So see yourself that you are given 5 minutes to express yourself. So express yourself in 5 minutes. Don't go to the nitty-gritty of theories, because that one we have been taught in the plenary. Thank you so much. You want to say something? So let's go for the group. What you want to say? Talk about the groups.
Yes, I think I can say something about the groups. The afternoon group of yesterday will be in the conference hall, and they will be under Mr. Gitonga. The program for today.
The presenters can follow me along this corridor. Those who are presented this morning.
So the presenters for today, that is those who are in the program. The upper water resource center will be this one. The lower water resource center will be the room down there. But for all the presenters for yesterday, will be at the conference hall. So I think we can join in the rest for a group photo. Thank you.